Assalamualaikum. My name is Munazza, and today I am here to present the topic related to the scheduling algorithms or the CPU scheduling. And the most relevant book related to the operating system is the 10th edition, written by the Silver Shorts. So, the course learning outcome of today's lecture is the application of the scheduling algorithm that is related to the GA2 and BT level C3, cognitive domain C3. So, outline of the today's topic include process scheduling, scheduling criteria, scheduling algorithms, and the scheduling algorithms include the first come first serve shortest job first. We have also the other algorithms, but today we will only discuss about the FCFS and SJF. Before starting that, we will discuss about what is the process scheduling or the types of the schedulers, and after that we will discuss about the scheduling criteria about the processes. So, objectives of today's lecture is to understand the role and functionality of the CPU schedulers in the operating system, to describe the various CPU scheduling algorithms used in the operating system, and to illustrate the working of the CPU scheduling algorithms through examples. So, process scheduling, before starting the topic of the process scheduling, we must understand what is a process. So, process is a program in execution. For example, if we have certain set of instructions, we call it the program. Whenever we will execute those instructions, it becomes a process. So, for example, if we have a span of the processes or multiple processes at a time, operating system have to decide which process should be executed first. So the process schedulers do this work. So the process scheduler selects among available processes for next execution on the CPU. The process scheduler selects the processes from the set of the process which should be executed by the CPU, and various queues are maintained during this scheduling. So maintaining the queues for the processes include job queue. Job queue includes all the set of the processes in the system, and the ready queue includes all the processes that are ready to execute, or that are residing in the main memory, or that are ready and they're waiting to execute. And the device queues include those set of processes to whom the CPU was allocated, but due to some reason, for example, the process waits for the input output device, so it will be sent to the device queue or the block queue. So the processes migrates among the various queues as before executing the process is in ready queue. So whenever the CPU will be allocated to a process, it will be sent to the running state. And if the process completes its execution, it will be completed. Otherwise, if the process waits for IO device, it will be sent to the device queue. So processes migrates among the various set of queues. Next is the type of schedulers in the operating system. So we have three types of schedulers in the operating system. First one is long-term scheduler, second is short-term scheduler, and third one is medium-term scheduler. For example, if we want to understand this topic by the real life example, by considering the real life example, we can say, for example, admission office works as the long-term scheduler. According to the classroom analogy, the admission office decides which students are allowed to enroll in the class out of all participants. Multiple students apply for a certain program. For example, in the BSCS computer science program, multiple students apply to enroll in that program. But according to the seat, specific number of students will be picked up for that program. So here, if we have multiple processes, but it's not possible to execute all the processes at the same time, so the operating system, in terms of the scheduler decides which processes should be put into the ready queue for the execution purpose or for the ready state. So 100 students apply for the course. The classroom memory can only handle the 40 at a time. So the admission office will select the 40 students. For example, we have the 100 processes at a time, but the scheduler will pick the set of processes that could be executed and will send them those processes in the ready queue. Afterwards the CPU could be allocated to those processes. So in terms of the operating system, it decides which processes will enter in the system for the processing. So the short term scheduler acts like a class teacher. A classroom analogy, we will understand this topic using the classroom analogy. Inside the classroom, the teacher decides which student will answer or present the next topic. So for example, a student asks some questions for example, teacher asks some questions from the students. So all students raise their hand and they are ready to present their topic, or they are ready to answer that query. So that means the all processes or the all students are in ready state. So the teacher call out one student at a time to speak. So for example, a teacher call out one student to speak. So in the case of the operating system, we have multiple processes that are in the ready state, but the operating system, the short term scheduler will select specific processes from the ready queue one by one, let's say for the execution purpose, and assign the CPU to that certain process. So if a student take too long, the teacher says time's up, next. So that means the preemption of the task is done. So that means, for example, if we have a process and the time slice of the process is 4 or the 5 milliseconds, if the process will not complete in the 5 during the 5 milliseconds, it will be preempted forcefully by the operating system, and to other process the CPU will be allocated. So role in term of operating system, it selects which ready process will get the CPU or the processor. So the short term scheduler picks processes from the ready queue and give them the CPU time. Medium term scheduler, considering the coordinator example, the class coordinator monitors the classroom and decides the class is too much crowded. So let's send few students to the other classroom or the other lab. After that, after certain period of time, whenever those students that reside in the lab number 1 will complete their task, the other students will be asked to come back to that lab. So in terms of the operating system, the it's temporarily or the for certain period of time suspends the processes. After the certain period of time, it resumes that processes to manage the resources of the memory. So basically, the medium term scheduler perform the swapping, moving process between the main memory and the secondary storage to balance the load. So we have multiple processes. We operating system can't manage all the processes at the same time. So some of the processes will be swapped out from the memory, the other process will be executed first. After that, the swapped out process will be swapped in the memory and they will be executed. So, what is the concept of primitive and non primitive scheduling? In non primitive scheduling, once the CPU has been allocated to the process keeps the CPU until the process itself switches from running state to the waiting state, or running state to the ready state, or waiting state to the ready state. So, in non primitive scheduling, operating system cannot forcefully stop the execution of the process. So once the CPU will be allocated to the process will release the CPU or the resources whenever it will complete itself, or whenever it will wait for certain IO devices. So the process will be sent from the running state to the waiting state, or from running state to the ready state. Whenever the operating system will send the process from running to the ready state. For example, a process have a quantum or the time slice of 4 milliseconds, but it do require the 5 milliseconds. So after 4 milliseconds, the process will be sent to the ready state and another process will be executed. In primitive scheduling, the execution of the process is forcefully stopped by the operating system. So the scheduler may suspend the execution of a process before it is blocked. So process is not completed, not terminated by itself. The operating system forcefully can stop the execution of the process. That means it is the primitive scheduling. So, primitive scheduling, in which cases we use the primitive scheduling technique? If a process with a high priority enter the system, if we have a system and we are executing the lower priority process and a high priority arrives in the system, so the higher priority process will be executed first and lower priority process will be executed after the high priority process. For example, if the higher priority process is waiting to be executed, so higher priority process will be executed first. Or if a running process completes its time slice or the time quantum, then after that completion of the time quantum or the time slice, the other process will be executed first. So, what is the scheduling criteria? Scheduling criteria includes the CPU utilization, throughput, turnaround time, waiting time, response time, and the priority. The CPU utilization means that we should utilize the CPU on its maximum. Keep the CPU as busy as possible. Throughput means the amount of work done in per unit time, and the turnaround time is from time calculated time from the job submission to its completion, is the basically the turnaround time. Whenever we want to execute a process, we will submit that process to the operating system or the system. So whenever the process will complete, so the calculated time from the initial state to its completion state will be the turnaround time. And the waiting time is whenever another process is executing by the CPU, so the other process in the list, for example, we have P1, P2, P3, P4. If P1 is executing, that means P2, P3, and P4 are in the waiting state, or they are waiting for a certain period of time to get the CPU. Response time, it is the amount of time that it takes from when a request was submitted until the first response is produced. And the priority, if the operating system assigns priority to the processes, the scheduling mechanism should favor the higher priority process. So, what is the optimization criteria? We have discussed about the utilization, throughput, turnaround, waiting time, response, and the priority. We should know that the CPU utilization should be minimum or the maximum. The throughput should be minimum or maximum. The turnaround should be minimum or maximum. So, according to the optimization criteria, the CPU utilization should be maximum. The throughput should also be maximum, but the turnaround time of a process should be minimum. The waiting time for each of the process should also be minimum, and the response time of the processes should be minimum. So processes should wait for less period of time, process should complete in minimum period of time, and they should respond in minimum period of time. But they should be but it should be the higher, having the throughput higher, or the utilization of the CPU should be higher according to the optimization criteria. So next we have CPU scheduling algorithms. The CPU scheduling algorithms are classified into two forms. First one is the primitive scheduling, and second is the non-primitive scheduling. Primitive scheduling includes the priority scheduling, shortest remaining job first, longest remaining job first, and the round robin scheduling. We will discuss these in next lecture. But in non-primitive scheduling include first come first serve, shortest job first, the longest job first, and the highest response ratio first. So before starting or the moving towards the FCFS, first come first serve, for the shortest job first, we should remember that how we can calculate the turnaround time and the waiting time. As we have multiple processes, and all process may arrive at the same arrival time, or they may arrive at the different arrival time, so we will have to plot a Gantt chart. After that, we will have to calculate the turnaround time and the waiting time. So the turnaround time can be computed by using the completion time of a process and the arrival time of a process. For example, if we have processes P0, 1, 2, 3, and 4, and all processes arrive at the time 0 milliseconds, that means the arrival time of all processes will be equals to 0 milliseconds. But what is the completion time? So whenever the CPU will be allocated to a certain process and the process will complete its execution, it will be its completion time. So we have to deduct the arrival time from the completion time to get the turnaround time. And accordingly, to calculate the waiting time, we will use the turnaround time. So we will deduct the burst time, that is the total time required by the process for the execution, from the turnaround time. So we will get the waiting time. So whenever we will use FCFS, SJF, round robin, or any other scheduling technique, we will have to calculate the turnaround, the waiting time, and the average turnaround and the waiting time. So, what is first come first serve scheduling? FCFS algorithm, the process that requires the CPU first is allocated in the CPU first. So, we have the multiple processes P1, P2, P3, P4. So, which process will arrive first? It will be executed by the CPU first. So, which process will come first? It will be served first. Implementation of FCFS algorithm is managed with the first in first out queue, as according to the queue description. Which process will come first? For example, which process will be at the index 0, it will be executed first. Which process will come, let's suppose P1 will comes after the P0, then P1 will be executed after the P0. And also we should know that the FCFS scheduling is non-primitive. That means the operating system cannot forcefully stop the execution of a process forcefully. It will be completed and then release the resources, or it maybe it will wait for a IO device, so it will be sent to the block state. So considering the real life example of FCFS scheduling algorithm, so consider the banking scenario. We have a bank teller, a queue in the bank, and a queue contains the multiple customers. Uh, 1 2 3 4 5 6. So according to the operating system, these six customers are our six processes, will be our six processes. So customer 1 comes for to deposit the transaction, customer 2 comes for loan inquiry, customer 3 comes for the withdrawal. So customer arrives in order, so the bank teller will communicate those customer in the same order in which the customer arrives. So it will be they will be served in the arrival sequence. For example, the customer 1 comes first, so he or she will be served first. Customer 2 comes after the customer 1, so he or she will be served after that. So as you can see, all other customers are waiting for the starting customers. So there is a no priority order, so no other customer who comes afterwards, the who comes later, will not be served first. So basic idea of the FCFS is the customer who comes first, he or she will be served first. So, according to the FCFS scheduling algorithm, let us discuss about an example considering the multiple processes. We have P1, P2, P3, and the best time of the P1 is 24, for the P2 is 3, and P3 is 3. Suppose that the process arrive in the same order. That means P1 comes first, after that P2 come, after that after the P2 P3 comes, and all these processes comes at the same arrival time, that is the 0. So firstly, we will have to draw the Gantt chart. So starting how we will draw this Gantt chart or the plot this Gantt chart. As the three processes arrive at the same time, that is the arrival time 0. So P1 comes first, so CPU will be allocated to P1. So whenever P1 will complete its execution, then CPU will be allocated to P2, and whenever the P2 will complete its execution, then CPU will be allocated to P3. So as you can see, P1 total burst time of the P1 is 24 milliseconds. So CPU will be allocated to P1, and P1 will complete its execution at 24. P2 required 3 milliseconds. So for the starting 24 milliseconds, the CPU was allocated to P1. After that, the CPU will be allocated to P2 for 3 milliseconds. That means P1 completes at 24, and we will add 3 milliseconds of P2, so it will become 27. After that, the P3 is already arrived in the ready queue, as the arrival time of all these processes is the same. So P3 comes, the best time of the P3 is 3. So for the P3, the CPU will be allocated for the 3 milliseconds. So we will add 3 in the 27 milliseconds, so it will become 30. So as you can see, P1 will complete at 24, P2 completes at 27, and P3 completes at 30. So how we can calculate the waiting time? As we all know that the calculate the waiting time, we should first calculate the turnaround time. So how will calculate the turnaround time? We will deduct the arrival time from the completion time. So as the arrival time of all processes equal to 0. So We can calculate it here. For example, the turnaround time of P1. So how we can calculate it? Completion minus arrival. So P1 complete at 24. So arrival of P1 is 0. That means turnaround time will be equals to 24. As P2 comes, so as P2 completes its execution at 27, so turnaround time of the P2 will be calculated as 27 minus 0. It will be equals to 27. P3 completes at 30, so 30 minus 0 will be equals to 30. So the turnaround time will be calculated against each process, and the waiting time will also be calculated against each process. So how we will calculate the waiting time? The turnaround time of first process is 24, second process is 27, and for the third process it is 30. So we will compute the waiting time by considering the completion time and also the bus time. So the P1 bus time is 24 and the completion is 24. So 24 minus 24 is equal to 0. That means the P1 process waits for 0 milliseconds for the assignment of the CPU. So next process completes as 27, and the bus time of the P2 is 3. So 27 minus 3 is 24. That means the P2 waits for 24 milliseconds. And also the P3 completes at 30. So 30 minus 3 is 27. So as you can see in the Gantt chart, P1 waits for 0 millisecond for assignment of CPU, P2 waits for 24 millisecond for assignment of CPU, P3 waits for 27 milliseconds of the assignment of CPU. After calculating these, we will calculate the average waiting time and the average turnaround time. As you can see, the waiting time for P1 is 0, P2 is 24, P3 is 27, and the average waiting time can be calculated by by the sum of the P1, P2, P3 waiting time divided by the total number of processes. So we will add 0 we will add 0, 24, 27, and will divide them by the total processes that are equal to 3. So we will get 17. Next is the shortest job first. In the shortest job first scheduling, we have multiple processes. For example, P1, P2, P3. The best time of which process will be the shortest, it will be executed first. It is the execution of the process does not depend on the arrival of the process if P1 comes first, but the best time of the P1 is 3 millisecond. Then afterwards P2 comes and P2 require 2 millisecond. So according to the shortest job first, P2 will be executed first and P1 will be executed after P2, as the time of the required time of the P2 is shorter than the P1. So, the primitive version, if we discuss the primitive version of shortest job first, it becomes the shortest remaining time first. But today, I am only discussing about the SJF, that is the shortest job first scheduling. So, for example, by considering the next example, P1, P2, P3, P4, we have four processes: P1, P2, P3, and P4. And the best time of the each process is mentioned against each process. For example, P1 requires 6 millisecond, P2 require 8 millisecond, P3 requires 7 millisecond, and P4 require 3 millisecond. So, starting with the shortest job first scheduling technique, as we can see that P1 requires 6, P2 require 8, P3 requires 7, P4 require 3 millisecond. So, the shortest time required by the process is the 3 millisecond, that is of P4. So that means the CPU will be allocated to the P4 first. So it is not the primitive version, it is non-primitive version of the scheduling algorithm, that means SJF. So P4 will complete its own execution. It requires 3 milliseconds. P4 executes for the 3 milliseconds. Afterwards, we will compare 6, 8, and 7. So the shortest time is 6, that is of P1. So P1 will be executed for 6 millisecond. After that, we will compare 8 and 7. So P3 consumes want to execute for 7 milliseconds. So P3, so CPU will be allocated to P3. Afterwards, the CPU will be allocated to P2. So how we can calculate the turnaround and the waiting time? Same mechanism will be used for all the techniques, for FCFS, SJF, round robin, SRTF, longest job first. For all the processes, for all set of algorithms, we utilize the same formula. For example, the turnaround time is equal to the completion time minus the arrival time. As all the processes arrive at the 0 milliseconds, so we will calculate the completion time first. So completion time of the P4 is 3. Completion time of P4 is 3, and P4 arrives at 0. So that means, how we can calculate the turnaround time of, I am writing T for turnaround time. Turnaround time of P4. Completion time is 3 and arrival time is 0. That means the turnaround time of P4 is equal to 3. The turnaround time of P1. So P1 completes at 9. So 9 minus 0 becomes 9. P3 16. 16 minus 0 is 16. And P4 at P2 at 24. So 24 minus 0 at 24. That means the completion time, the turnaround time is same as completion time. So we will calculate the waiting time. So waiting time is calculated by turnaround time minus burst time. So P4's turnaround time is 3 and burst time, so we will consider is it's also the burst time. So the completion time of, let's suppose P4 is 3, or the turnaround time of P4 is 3, and the burst time for the P4 is also 3. That means the waiting time for the P4 is 0 millisecond. 3 minus 3 is 0. So so as you can see in the Gantt chart, the P4 wait for 0 millisecond. Next is P1. P1's turnaround time is 9 and its burst time is 6. So 9 minus 6 is 3. That means P1 wait for 3 millisecond. The completion or the turnaround time, we have calculated the turnaround time considering the completion time. So P3, the turnaround time of P3 is 16. So 16 minus 7, we will it will be computed as 9. So that means the P3 waits for 9. And P2 turnaround time is 24. So 24 minus 8 is 16. That means P2 waits for the 16 milliseconds. So similarly, we can calculate the average turnaround time. We will add the turnaround time of the each process and will divide it by the total number of processes, that are 4, and we will add the waiting time of all the processes and will divide by the total number of processes, that are 4. We will get the average turnaround time and the average waiting time. So that's all from today's topic. So I will go through from the basic element that we will have that we have discussed today. Initially, we have discussed about the process. What is the process? So process is basically a program in execution. So we have also discussed about the types of scheduler. We have short term scheduler, long term scheduler, medium term scheduler. We have discussed about the scheduling criteria, that CPU utilization should be maximum, turnaround time should be minimum, response time and the waiting time should also be minimum. At the end, we have discussed about the types of the scheduling techniques. It could be primitive, non-primitive, and first come first serve scheduling, along with its example, the shortest job first, along with its example, and the computation of its turnaround and the waiting time. So that's it for today's topic. So thank you so much.